Hello everyone, thank you for joining us. This is our webinar on teaching statistics with Maple. It's going to be a slightly different webinar. It's something that we don't typically talk too much about with Maple, but it's a pretty exciting topic and I want to spend some time talking to you about it. I'm going to start by a couple of notes. So I think, in the history of what I've seen, one of the biggest risks of using a software package in classroom today is that the software can obscure concepts. I think this is a commonality between math and statistics, engineering, wherever you are working today. And I think this maybe comes out of some of the other tools that are conventionally used in a classroom. Sometimes having an interface that might be a little bit more hard to use, maybe sometimes requiring students to master a complex programming language before they begin. Maybe even the interface that you're using, it doesn't show any of the underlying concepts at all. Instead, it basically obscures everything underneath buttons or pop-up dialogues that simply perform an action and give you a final result. So I guess what I'm going to be after today is I'm going to show you some of the things we can do inside of Maple that have typically been used maybe more within the mathematics department. And it's kind of been this best kept secret for a long time. So we want to show you some of the ways that, that Maple can also become a viable alternative for teaching statistics and probability. So what I'm going to focus on today is how we can use Maple to provide both the ease of use of a point-and-click system as well as access to this robust programming language for the advanced statistical computation that you might need. And I really feel like with this combination, matched together with what we have in a technical document interface, there's also pre-built interactive applications designed for statistics education, tools for building custom content. All these things combine to make Maple a powerful, flexible environment that can really enhance your statistics classroom. So that's my preamble. I'm actually inside of Maple right now. What you see on your screen is a Maple slideshow. So I'm going to flow through my Maple slideshow a little bit and show you a couple of slides here just to kind of give you a little bit of history before I go back into the main talk. So as I said, historically, Maple has been known as this powerful tool for math, statistics, engineering, science, programming. It's also been known to be a place where you can go to do documentation. So it's kind of like a Word with a math engine in a lot of cases. So you can do document prototyping, reporting. And what you can also do is you can use Maple to develop interactive applications. And this is something I'm going to spend some time talking about later on in this talk. But let me show you a couple of examples. So this is kind of one of the keys of Maple. Maple is an environment that allows you to do both symbolic as well as numeric computations. It's what we'd refer to as a hybrid environment. So here are a few examples. Here we have arctan of 1, the integer 1. And when we enter this into Maple, we get a result back of pi over 4. So this is what we refer to as a symbolic, it's an exact result. There's no approximation that's happening here because the result here is literally pi over 4. Now if we did the same calculation in the floating point domain, we do arctan of 1.0, we get this result back with 10 decimal points of precision. So here we have arctan of 1.0 is going to equal to 0.785398 and so on. Now the power of Maple is that it not only allows you to do symbolic as well as numeric computation, it allows you to do so with arbitrary precision. So on the next line here, eval_f, that's a command in the Maple language for evaluating using floating point arithmetic. So we do eval_f of 100 of the result on this line, and this is this pi over 4 approximated to 100 digits. Now of course you can go in here, you can put your cursor here, you could go to 10,000 or 100,000. You could fill up your memory in your computer if you really wanted to. Maple will allow you to do that. But of course that comes at a cost of increased computation time as we're working with more and more precision. But it's there, you can use it if you'd like to. Another key for Maple, and I'm going to spend a little bit of time talking about this in terms of statistics in just a moment, but with Maple you can use natural math or statistics notation. Right, so here we have a derivative, so d over dx of x squared plus cos of x, and its result. Now this is valid input in Maple. You could use the code language if you wanted to, but this is a viable alternative that you can use to input expressions. So as we get into these statistics examples, which I'm going to show you in a second, this is going to really reinforce the idea that the students interact directly with expressions using standard textbook notation. So let me show you a couple of examples of exactly that. So I'm going to start here. I'm going to load up the student statistics package. So I'm just going to use this with command here. And then I'm going to use a couple of random variables generated from this student random variables palette over here on our left side. So if you don't have this open inside of Maple, you're curious where this is, you can right click over here in your palettes, you can go down to student random variables and turn that on or off. So for now, let me just insert a new normal random variable, and we'll see by default it's mu and sigma. So let's just leave this symbolic. So I'll just hit return here. And there we get back a new random variable object. So this is kind of the key. This is what you need to start working inside of Maple. I'm going to open up this panel over here, and this is usually open by default inside of Maple. But if we open this up, we now get options which are relevant to this random variable. So this is what we've referred to as clickable statistics. So we're able to do a number of different operations directly to input inside of Maple, just using a simple click of your mouse. And this makes it really, it's supposed to, for the student's perspective, it's designed to support interactive learning, allowing the students to concentrate on concepts, not necessarily even needing to worry too much about the commands or the syntax. So let's look at a couple of properties of the normal random variable that I've generated now. So let's go to properties, and let's go to quantities first, and let's go down to mean. So there is the mean. As we could expect, it's mu. All right, we would have known that one from before. Quantities again, we'll confirm standard deviation is sigma. Go back to our random variable here. All right, let's do something a little bit more interesting. Let's do properties CDF. Then we get a dialog box popping up, and let's do the CDF computed at X. I'm just going to press X on my keyboard, hit OK. And there is our CDF for the normal random variable. Now, if we have our cursor here, you'll actually see that we're able to do a number of different operations. So the context manual is switching as we go. So now that we've kind of entered in some expression, we're able to do some different things with it. We can do some 3D implicit plots if we really wanted to see what this looks like in different domains. We can factor it, we can solve this, we can integrate it, we can kind of do all that magical stuff that you have available to you through Maple as the Maple language. All right, but let's talk instead about visualizing the normal distribution. So let's move on. So I'm going to do an assignment here. Let's assign X to be equal to a normal random variable with mean 0 and standard deviation 1. So this is the standard normal distribution. All right. Now there's a command inside of the student statistics package called sample. And what sample lets you do is it lets you sample the distribution you've created or the random variable you've generated. And the second argument here is the number of elements in your sample. So we do my sample, and here is 1,000 data points produced in this vector. All right, so I'm going to do a couple things now. Let's go back, put our cursor back here on the normal random variable with 0, mean, and standard deviation of 1. And let's quickly find the properties, and let's grab the PDF at value X. So there's our PDF. All right, let's go down here, put our cursor on this data vector. You'll see now there's lots of different options available for you here. We can go to statistics or student statistics, either one. There's lots of different options here. There's plotting and so on. Let's do a quick histogram. So let's go to visualization and let's do a histogram of our data. So this is the interactive version. So this will actually end up giving you options to change the plot that you're generating. I'll just press quit here. This returns the plot for us. If you want to just have a straight up histogram without the interactive version, you go to plots, data plot, histogram. That'll work as well. Doesn't really matter, whichever way you prefer. So one of the nice parts about being able to use Maple is that we're able to now mix and match a little bit. So now we've created a quick data plot, which is showing us this the values coming out of the sample we took from the normal distribution. And of course, we can kind of see the curve here, right? If we've taken enough set data points here that we're seeing the normal curve. So, but let's actually go up here, and I've got the PDF which I declared before. I can go up here, select this math, drag it down and drop it right on top. And now we can actually see the red lines here. And let me just do something here. I'm going to press Control on my keyboard and just zoom us in a little bit so we get a little bit better view. Maybe let's go in a little bit closer again. So here we can see as our data that we sampled, as well as the actual curve for the normal distribution, the PDF sitting right on top there. So we're kind of interjecting, we're kind of mixing and matching a little bit here. We're moving from the math to the plot. And this is a very, very straightforward and easy to do within Maple, that you're able to just grab some math, and I'll just click on this plot again, I'll press delete. I'll go back up and show you how I did that again. I just selected that math, dragged it down, dropped it on top of my data, and you're able to put that right on top of the information. So you're able to really kind of showcase these properties that you'll be able to show after having done this type of similar example in the classroom. All right, let me show you a couple more examples. Here's kind of one of the powers of using Maple again, is I'm going to load up the statistics package this time in order to make a new distribution. And let's make a new half normal PDF. And this is just a function declaration of Maple. So X here, it's kind of mapping on to this piecewise function. So it's going to be 0 and when X is less than 0. And for everywhere else, it's going to be this expression here, which is the PDF for the normal distribution. All right, so I'll just declare that. So half normal PDF is this. Then the next command we do here is our new dist variable is going to be equal to statistics distribution. PDF is equal to half normal PDF. And then once we've done that, we again have now declared a new random variable. We can start working with this random variable or this distribution. So mean distribution, this will give us back the mean, or we can sample directly from that distribution. So sample dist, get 100 data points from there. Now we can go over here, plots, data plot. Let's do a box plot just to see what this looks like. Here's our values. So we're able to very quickly generate new distributions, sample from those, kind of mix and match and work with whatever we'd done previously. All right, another example. I'm just kind of going through a couple of examples here very quickly. Probability. Here we're able to the probability that a normal random variable with mean 0, standard deviation 1 is less than 1. And actually, I think I'll have to just load up our student statistics package here, because this normal random variable command comes from the student statistics package. And that is the probability right there. The normal random variable is less than 1. All right, we do also have other commands. We have actually within our tutors, this is probably a good tangent now. We go tools, tutors, and you'll find within the statistics menu here, if you did want to look up values, say probability distribution tables, things that are usually in the back of your textbook, we have interactive tables that you can also produce on the fly by clicking either this or the critical value tables within the statistics tutors menus. I won't show those today, but I'll leave those for you guys to look through and experiment with. But let's run a couple more examples here, talking a little bit more about looking at some data, some more information. Now, there's a generic command called import inside of Maple. And what import does is it looks at whatever string you give it, whatever file you're giving it, and it just tries to coerce it into a data type inside of Maple. And if I look here and try to import a file that's stored inside of our data directory, if that data is contains any type of column or row labels or header information, Maple will often try to coerce this into a data frame. So in this case, what we've done is we've imported the iris dataset. It's a fairly famous dataset. It has 5 columns of information. We have these 5 variables: sepal length, sepal width, petal length, petal width, and we have a species column. Now, within these columns, so this is what we consider to be heterogeneous data. We've got 4 columns here of floating point information, and 1 column where we have categorical factor information stored as strings in this case. So this is a little bit of a different beast that we're used to seeing inside of Maple, but it's just also, it's similar to maybe like a Maple matrix or a Maple R table or an array. So we can do a lot of the same operations. So if we've clicked on a data frame, we can first and foremost go over here and we can start to look at it. So let's choose describe from the top of the list. So if we describe the data frame, we see that these 5 variables are described. Anything that's numeric is given to you with min and max, and anything that is of a type factor, string, symbol, so on, you're going to get a tally, and it's going to show you each one of the levels. So here we have, there are 3 separate levels within the species column: Virginica, versicolor, and Setosia. Each of those has 50 elements. So there's 50 kind of subsets of this information that consists in this species column. All right, let's do a couple more things here. Let's go to summary and tabulation. This is kind of what the other thing that we typically do when we're starting to look information. And let's go to data summary. And when we do data summary, this will give us a column selector, so we can select to summarize the numeric information, and we'll display this in an embedded table. So here we can now see, okay, we're getting a 7-number breakdown of the information we've got in these columns. So this is doing this with, as we saw before, lots of decimal points of precision. We can kind of clean this up if we wanted to use an intertrace variable, but I won't worry about that for now. Again, we can do a lot of different things. We can visualize. Let's go to visualize, and let's do a box plot. Again, we'll use the column selector to select the numeric columns. And there are the numeric columns. Because this is a data frame, we also get any information that's stored within that data frame added to the visualization. So here we have a box plot of the 4 columns. We can go back and again do data analysis. So there's some principal component analysis. There's some ANOVA inside those menus there. Let's do something. Let's go down, and we could filter if we wanted to, but let's aggregate by column. Since we have a column with factors, let's choose to aggregate by species. We'll show the mean, we'll show a tally. And what that does, if I just zoom out a little bit here, so we now have some aggregate statistics. We've gone through and we've looked at each one of these subspecies here. So we've got the 3 subspecies, and these are the per variable column means. So you're basically seeing that each one of these different variants have very different mean values. So we can kind of get a lot further into data analysis. I don't want to spend too much time here because I think that could be potentially a whole webinar on its own, but this is kind of just a couple of very quick examples just to show you that, you know, it's not just the symbolic statistics there. There's going to be a full toolkit that's going to let you do a little bit of that data exploration, data analysis. But I did want to just very quickly close off this section by just kind of going back and reiterating something about this symbolic term here. And this is something I do find quite important about Maple, in that Maple is fairly unique in offering that integrated symbolic computation for statistics. So a lot of the other environments that you might be using today are going to be strictly numeric, right? So that's not to say that you shouldn't use those as well, but there's a lot of cases where if you're using Maple within that course for, say, mathematical statistics or first year intro to stats or probability, there's going to be a case where there's going to be an importance for you to use symbolic mathematics, right? So I think this is one of those cases where Maple can really come in and provide more realistic and engaging problems where students are kind of getting a little bit more focused on the understanding of the statistical theory when they're still focused on learning the actual mathematical notation itself. All right, now bridging the divide, kind of showing you a little bit more of how you can use the Maple environment. I want to talk about the Maple document interface. So everything we've been walking you through so far has been inside this Maple document, all right? We've had a Maple document. It's been a slideshow for us. I can press F11 here to go back into my slideshow mode and walk you through all this. But the key part is that within a Maple document, it's like a Word document. You can collect together text. You can have math. You can have data tables. You can have plots. You can have everything in one place. When you have generated a nice document, you can go to File. You can go to Export As. And you can export your file directly to HTML, to PDF, to LaTeX. So you can go directly from prototyping or doing your report inside of Maple to various file formats. So this is pretty important, and this is something we've seen getting as a reason to use Maple more and more in the classroom. And one of the ways we've seen Maple be used today is to generate these things we call math applications, or we can extend that. We'll call them stats applications as well. So here we have a collection of interactive Maple documents. That's really what these things are. So with these interactive documents, what you get is an opportunity to explore some subject. So let me click on one of these. Let me go into rolling 2 dice. And I'll just press no here. This is going to replace it in place. So rolling 2 dice. This is another Maple document. So at the start of this document, I'll just close off some of my interface here just to save us some screen real estate. So at the start of this document, we outline what the concept is. So here's the problem that we're looking to solve. So what is the chance that you roll 2 6s? We're talking about rolling 2 dice here. And we're going to go through, we're going to list the full list of combinations, the outcome, the probabilities. But more importantly, skipping past all the introduction here, is you have something interactive at the bottom. So let's say that the first dice is a 3. This is the probability the first dice is a 3. So this exists with probability 1/6. Now let's further kind of whittle this down. So let's go right die is a 2 or a 3. We kind of see, okay, probability is 1 out of 36 now. Let's say both sum to 5. So that's this diagonal right here. Both sum to 7. That's the center diagonal. And we're seeing the probability table down here being reflected. So this is a simple app, but the key part here is that what we have is an interactive application that the students are experimenting with. So you're able to hopefully bring some of the concepts to life. And what we've done with all these different applications, if I go back to my demonstration here, so for probability, for statistics as well, is we've gone back to the textbooks. We've gone back to scratch, and we have tried to include applications that walk you through those problems that you're going to encounter in the first couple of years. So we see here there's lots of problems in probability. There's coin tosses, there's rolling 2 dice, there's the Monty Hall problem. And same thing for statistics. We're going to walk you through the central limit theorem. There's confidence intervals. There's all the different tests and distributions are outlined here. So there's a lot of interactive documentation that's all available to you. So you can experiment with this inside of Maple. And of course, we do have this freely available online as well. And I'll just show that to you in a second. But I'll just show you another one here. Let me just pull up another example. Let's do Monte Carlo approximation of pi. And open this one up, Monte Carlo approximation of pi. Again, we walk through the background here. And down below, there's something interactive. So we can start dragging at this slider here. And we see here, as we get closer and closer to a higher number of dots, we're going to get closer and closer to the actual value of pi. So here we have an estimated value of pi. Here's the actual value of pi. So as we get higher, well, this is just randomly sampling, so it may or may not get a little bit closer. There we go. As you can see here, we can kind of get closer and closer. So it's an interactive application. Students are meant to just interact in order to learn the concepts as they're going here. So there are tons of different applications inside of Maple. As I said before, these are also freely available on our Maple Cloud. So let me switch over here to a web browser. I'm going to go to maple.cloud. So if you just simply type this into a web browser, this will bring you to our Maple Cloud. So within here, you can go to Math Apps, and I'm just going to sort by date. I think I've added some for statistics lately. We'll see here. I'll scroll down a little bit. Sure, here's one for the correlation coefficient. So I'll open this up in the Maple Cloud. It looks very similar to what you see inside of Maple. You have an explanation of the correlation coefficient. And I think in this one, yeah, we can click out some points. And then here we are fitting the line to it. We're getting our R value. Maybe I'll add some values down here so we can kind of bring the R value down. So it's an interactive application. It's freely available in the cloud. You don't have to be signed in. You see here that I'm not signed in or anything like that. You can just go and access this directly through just a URL sitting on our cloud, right? So that's another neat part about Maple, is that you are able to use it to build interactive applications. So by way of segue, I think I've shown you a couple of examples of these. There are tons more. If you go to Tools, Math Apps in Maple, you'll see a whole bunch of different applications. You'll be able to use all those, hopefully within the classroom. But another thing that Maple does is it makes it easier for you to actually create applications. So down here, I've got a couple lines of code. I'm doing an application that's going to explore a smoothing constant. So let me just run the code here, and I'm going to use a command in Maple called explore. So explore is kind of our application builder. If you run explore on a plot, on an expression, on a procedure, you can have it generate plots or mathematical expressions, whatever you want. But in this case, what I've done is that I've used it, we won't worry too much about this, to sample some data and then fit it with a curve with a smoothing constant of a certain value. So here we can now drag the smoothing constant value out, get closer and closer to 1 where we have a complete fit, or we can kind of drag it down this way too, starting at 0.1. So this example is pretty trivial. It's not a very complex example. But the key part here is that explore, as well as procedures from the Maple language, let you create something that is entirely interactive. If I now take this and save it, I could put this, say, in the Maple Cloud as an example, then students have access to something that's interactive, that's been created with this one line of code. I mean, this is all the code I need to create the application. This is just doing a procedure that lets me mix and match a couple of Maple commands from the statistics package, like cumulative sum, line chart, exponential smoothing, and line chart. But the key part here is Explorer is kind of the glue that makes this interactive application for you. So actually, I'll show you another example. I was playing with this one just yesterday. This is a collecting points application. This is another example of something that you can do using Maple's interactive interface. So here's an example. I was working with a high school teacher on this one. So the question was, students want to connect real life structures, maybe a roller coaster or some other thing. So they want to click out points that define a curve and then fit those points with a curve. So here, hopefully everybody can see that there. It's a red line has now connected through all those yellow points I've created on our plot here. And we can reset this if we wanted to. We can also just go through and just do something random here, fit that point, and obviously it's going to be a little bit worse, right? So again, we have an interactive interface. You're able to experiment more. It's kind of more of a playground for devising different types of applications. Now, I've actually added that same application to our Maple Cloud. So if you go back to our public Maple Cloud, I think I just added this one yesterday, you can play with a variant of that called fitting collect points within our Maple Cloud, where you can go in and have students click out points. You'll see here that our data array is growing as we're clicking. Fit the points with a curve. Here's the fitted expression, and here's what that curve looks like. So again, this is just freely available in the cloud. You can just go and grab a copy of that and play with it. So again, I've talked a lot about Maple Cloud now. I don't need to spend too much more talking about the cloud, but it's really a great tool that you can use to complement what you have within the classroom today. Now, last but not least, I want to spend some time talking about connectivity. I'm going to be realistic for a second here and talk about the fact that within Maple, it's a great environment for doing a lot of the exploration that we've seen today. You know, we can talk about symbolic statistics, we can talk about interactive documents, we can talk about all these different tools for clickable statistics that we've already interacted with. But realistically, there may also be a case where you may want to use Maple as a first level tool and then have students transition into using different environments, or maybe using Maple in conjunction with different environments. So Maple can do a lot of this. I'll just make this a little bit bigger. Maple can be a part of various tool chains for you. So Maple as a language it's a very robust language. You know, we've been building Maple as a language for over 38 years. It's a very, very robust language. There's over 6,000 commands inside of Maple. But we also realize that there's other commands, languages out there. There's also things that you want to work with. So you can do things like call external call from C or Java. You can call Maple itself from those other languages as well. So you can call in from a C or Java to get some type of interaction from the Maple kernel. We can do things like generate code for various other languages. I'll show you that in a second. We can also do data import and export. I showed you an example before of importing a data file from Excel. It can be CSV, Excel, it can be matrix formats, it can be MATLAB formats. There's also connections. So we can be used as a symbolic toolbox within MATLAB. You can use us to solve more problems within Excel. We can connect to online databases. We can be used for any type of online searches as well. But very cool stuff. I want to kind of end with this stuff. There's two new things I want to show you. One is a new tool within Maple 2018. We've got a connectivity here. And Maple 2018 actually now even features a full Python kernel. So you don't even have to step outside of Maple. You can use Maple language and then use the Python package inside of Maple to just pass structures back and forth. If I scroll down here, we'll see that we can even do some more interesting things with Maple's integration with Python, because we've also added connections to the TensorFlow functionality for deep learning. So here we can interact through the Python package with TensorFlow. So there's a lot of interactivity there. You can actually stay within Maple to do some very, very cutting edge work. Something else you can do, if I go up here to Tools, Assistance, Code Generation. I mentioned before the idea of generating Maple code and then translating it. Here we have a Maple procedure. And on the right side of our screen, this is using our code generation package. We have the translated version of this code. So this is the translation for C. This is talking about statistics. Let's show you here. This is the translated version of the Maple procedure into R. Or maybe we'll translate this into Python. Or as we get moving forward, Julia. So we're seeing that Maple is also able to prototype some code for you. Now, of course, this comes with some caveats. The Maple's code generation is something that we're working on all the time, so it's going to get better and better, but sometimes there aren't mappings in other languages. But this will get you along the path of translating some code that you may have prototyped inside of Maple, where you have access to symbolics, and then you prototype that, you go over to another language, you maybe have some other library that you might be using for something else. So I mentioned that as kind of a last point because it is one of those things that can add a lot of value to your experience, but it can also add value to the student's experience, right? Because it gives an opportunity to use this tool that they've learned calculus, learned linear algebra, learned hopefully introduction to probability and statistics in, and they can use that to prototype their code, to send it to a different language, to kind of complete a full toolkit and a tool chain as they transition out of university and maybe into industry. All right, so I'll close this off there. I'm going to leave a couple of our social sites on the page for a second here, but I guess what I really wanted to emphasize with this talk today is I think it's well established that the right software tool can really enrich a classroom. It can help to engage students, it can improve learning. And it's my hope that for statistics education, Maple provides provides a comprehensive environment that both offers this ease of use features, kind of some of that clickable stuff we saw before, as well as this full access to this math computation engine, as well as the Maple language, that makes it a powerful, flexible alternative for statistics educators. And we really do feel like Maple is this tool that can grow with your students. And this is kind of restating what I said just a second ago, that you can use it for those introductory courses, but then you can use it to transition into graduate school and the workplace. So it's really a robust tool. It's been a tool that's been really the best kept secret by math classrooms for a very long time. It's something that we're hoping that will enrich your statistics classroom tomorrow.